Okay, thank you guys so much. And let's go into what we're here for. Thank you guys for joining us. We are doing a webinar here for the Women Who Code Python track. For those of you who are new to Women Who Code, we have some intro slides for that. So our mission is to inspire women to excel in technology careers. So whatever that means, we want to do it. And then we also have our vision here, where we want to see women in the higher level positions, such as venture capitalists, founders, board members, and engineers. So that's kind of our goal and what our aim is. We also have a code of conduct for our members to follow. For more information, feel free to go online here, womenwhocode.com/code of conduct. Women Who Code Python is one of 6 tracks that were launched this year. So there are other communities you can join if you want to learn more about, data science, cloud, front-end, blockchain, or mobile. You can just go to womenwhocode.com and then append there that word like cloud where Python is. So yeah, the purpose of the tracks are to bring different resources to people who wouldn't normally be able to attend the in-person events. So all of our events are online, usually happening asynchronously as well. If you haven't already, we have a Slack channel that you guys can join and get some more information and join the community. Women Who Code Python, we have a few leaders now, so we're up to 5. If you are interested in becoming a lead in the Python universe as well, feel free to send us an email. We can definitely use all the help we can get. All right, so here's an example of one of the resources that we offer, which are job listings. I have an example here of one of the jobs that have been posted through Women Who Code for our community members. So you have access to all kinds of listings there. It's not just for like Python or anything. It can be whatever you're wanting to get into. We also offer some coding resources. So by becoming a member, you have access to our vault of any kind of tutorials or videos or like code along kind of challenges. So definitely take a look into that. And then of course we need people, so get involved. You can join our leadership team by becoming a lead or an evangelist. We need people to create content as well. We've all been there when we're trying to watch this tutorial or get through a tutorial and it's just not clicking. So we need more people out there to create a more diverse content for those who need that. And then another way you could get involved is just by sharing your story, saying how you're learning to code or what your position is in the industry and just growing with the community. And if you haven't already, you can join us on social media. We're on Twitter, Instagram, and Facebook. And I believe our handle for all of them is @WomenWhoCode. So we'll see you online. And then before we get into anything, we need to thank our sponsors because without them, we wouldn't be here. So thank you guys so much. We really appreciate it. It shows how much and how important this community is to not only them, but to the community. So thank you. And now we have our special speaker. So Gabrielle, if you want to go ahead and unmute and kind of share a little bit about yourself, that would be awesome.
Sure. Hi, everybody. I'm Gabrielle Rabinowitz, and thank you so much for that introduction. As you can see here, I am the lead teacher for the Bridge Up STEM program at the American Museum of Natural History in New York City, which is where I am right now. So this is a really exciting position for me. I am an educator. I teach this program to high school girls. It's a free summer and after-school program funded by the Helen Gurley Brown Revocable Trust. And our mission is really very similar to the Women Who Code mission. Our mission is to increase representation of women in computational science and coding and tech. So I'm very excited to be here with you all. How we do what we do is we bring these students into the museum. We give them the opportunity to learn Python in a science research and museum exploration environment. So they're having fun exploring the museum while they're learning how to code. And I'll go into a little more detail about that when I start my presentation. But just to tell you a little bit more about myself, my background is in science research. I have a background in molecular biology and a master's from Rockefeller University. And that's when I learned how to code. So I had, been interested in coding as a child and as a high school student myself, taken a little course here or there, but I'd never really dived into it until in grad school. I started working with data sets that were so large that they were crashing Excel. And I finally had to learn how to code and had the immediate application for it. And so that's when I started learning Python, and I was able to use it to do my data analysis in the lab. And now I'm able to share that information and spread that to students so they learn it much earlier than I did, and they don't have to learn it, in the last minute. Yeah, so that's who I am.
Awesome, thank you so much. So let's just go ahead and get right into it. If you want to start sharing your screen, I will stop and you can take it away.
Okay, great. So let me do that. Let me get these actually in presenter mode. Just a second. Okay, so does that work? You can see the slides full screen?
Sure can.
Okay, great. So I'm really excited to be presenting this webinar. This is a really topic that's very important to me and a topic that we focus on so much in our program. So this is Data Science with Jupyter and Pandas, Tales from Teaching Scientific Data Analysis. Our context is science research, but I hope that the lessons that we've learned and the approaches and tools that I use, you will find helpful regardless of what data science topic you're working on. So just a brief overview of what I will discuss in this talk. I've already given my introduction. I'll review what I mean when I say data science and scientific data analysis. Talk about the tool of Jupyter Notebook, the Pandas library, and then give you some examples of how we use these tools to explore scientific data. So I already mentioned this is who I am. Now I'll take a little bit more time to talk about the Bridge Up STEM program. So it's a multi-unit computational science and data analysis program for high school girls at the American Museum of Natural History. And it's a really exciting opportunity for them to not only learn how to code, but learn how to use those skills to analyze scientific data. As you can see on the bottom right there, they also get to go behind the scenes at the museum. This is the ornithology collection. And at the top right there, they're working on their computers. Bridge Up STEM is just one of many programs going on at AMNH at any given time. It's the only one that focuses on coding. But as you can see on the left there, this was the Summer Science Education 2018. A lot of students move through these doors and get a lot of great opportunities. What's very cool about the Bridge Up STEM program is that it's not just the summer and after school program that I teach, but the students, once they've completed that, they're then able to participate in a paid internship with the museum where they apply the coding skills that they've learned to a hands-on or computational science research project with a research mentor. We also fund those research mentors through our program. These are recent college graduate women who come to the museum and do a 50-50 research and teaching program. So this, if any of you are a recent college graduate, woman in computational science, and would be interested in the Helen Fellowship program, a paid one-year fellowship, you can look that up. And if you know any 9th or 10th grade girls in New York or the New York City area who might be interested in being a Brown Scholar, we encourage you to send them our way. It's a really amazing opportunity for them. So that's what I do at the museum. But that's not what you're here for. You're here to learn a little bit more about how we use data science. So as I mentioned, data science is really the emphasis of our program, but it can be a little hard to see what that has to do with science research at first. So this is a data science lifecycle graphic that I got from a data scientist online there. You can see his website, sudeep.co, in the middle. And I think it's a really helpful way to envision the data science lifecycle. Some of you may already be very familiar with this, but for others of you, it may be the first time. And I find it useful to look at these sorts of images even when you're relatively familiar with the field. So starting from the top there, Data science expects that you begin with business understanding so that you can ask relevant questions and define objectives for the problem that needs to be tackled, right? You have to know what you're looking at, and so you can ask the right questions. Once you know what you're working with and what your questions are, you can move into the data mining process, where you're gathering and scraping the data necessary for the project. Once you have your data, you move into data cleaning, where you fix the inconsistencies within the data and handle the missing values. Once your data is in a state that you feel confident you can work with, you move into data exploration, where you start to form hypotheses about your defined problem by visually analyzing the data. Next, feature engineering. This is a little bit of a buzzword, I think, and it's pretty specific to machine learning, but the main point here is that you're going to be selecting important features, constructing more meaningful ones, and using the raw data that you have. So starting to pull out some specifics from that data. Next, if you're using a machine learning approach, you can move into predictive modeling, where you train machine learning models, evaluate their performance, and use them to make predictions, although that's not the only way to analyze data and get meaningful results. And then finally, data visualization. Very often, a data scientist wants to communicate their findings using plots and other visualizations, sometimes interactive ones. So this is the data science lifecycle. How does that compare to the scientific data analysis lifecycle? Well, from my perspective, it's actually very similar. All we really have to do is swap a few terms here to see how these same steps are what we do in scientific data analysis. So business understanding, obviously we're going to have to change that. I consider that to be scientific domain knowledge, right? Do you know about the scientific topic that you're working on? One of the great aspects of our program at the museum is that we explore many different scientific domains. So the students could be working with an astrophysics data set, a climate change data set, one from molecular genetics, really all across the board. And we have scientific experts here at the museum, curators and researchers doing ongoing active research that we can work with and bring in their domain knowledge. You know, my own background is molecular genetics, so I've learned a lot of new domain knowledge in this position. But you have to know what you're working with to begin. Data mining, gathering and scraping is not necessarily the approach you're going to take in scientific research, right? You're more likely to have data that was either collected through an experiment or maybe field work, or maybe you're working with a publicly available data set collected by and provided by a government organization or something like that, or data that's been published in a journal, scientific journal. Data cleaning, that's not going anywhere. You're still going to be cleaning your data. Data exploration, absolutely the same. Feature engineering, I think we can rename that something like variable selection and calculations, right? You're still going to be processing your data, isolating variables to look at. Now, you may still be using machine learning and predictive modeling. Certainly, a number of departments of the museum are using that, and many other scientific researchers as well. And some of our students have used machine learning in their internship projects. Data visualization, absolutely, right? You're still going to want to communicate your findings. Maybe it's not a business stakeholder, instead it's the public or other researchers, but still the same steps. So I'm going to use this model, this system that we've just looked at, as a framework for the rest of the talk, where I'm going to walk you through how I go through these steps with our students and how you can do the same in whatever domain you're working in. So what tools do we use to do this? I mentioned Jupyter Notebook, it's in the title of the talk. Jupyter Notebook is an incredibly powerful tool for doing data science or data analysis. It's a nonprofit open source web application. It's one of the products of the IPython project in 2014. So it hasn't been around for that long, but it's already come to dominate the landscape, both in education and in professional data science. You can create and share documents with live code, equations, visualizations, and text, and it's a coding environment. It supports over 40 programming languages, including Python and R. I believe the name Jupyter was originally Julia, Python, and R, even though Python and R are the primary uses for it, and Python, I think, is the dominant one. So it's really powerful. What does it actually look like? It's very easy to download from the Jupyter website. You can pip install it, or you can use their downloader. The key thing to know about Jupyter Notebooks is that you're going to be working in cells. So as you can see in this notebook, which by the way is the very first notebook that my students use, which is why it says welcome to Jupyter Notebooks, you can see there it says this is an empty cell. Those gray boxes, some of which have little numbers next to them in brackets, that's your coding environment. So in Jupyter, you can write code in any given cell, and you can run those cells individually. This can be very useful and powerful, allows you to debug or work on one section of your code without needing to run in a really long script. Of course, there are some downsides to that. The downside is that you can start to lose track of which cells you've run in what order, and it can start to become problematic if you made some changes to a cell but didn't rerun it, but you're expecting that code to still apply to a cell later on. So it's something that you have to get used to. But once you're used to it, I find it a very useful and powerful coding environment. Those little numbers that I mentioned on the left-hand side in brackets, those are very valuable. They tell you the order in which the cells have been run. So you can see there's a 1, a 2, and a 3. If I went back and reran this var1 equals 5 cell, then that number would turn into a 4. So you can keep track of which cells you've run in what order. As you notice, this notebook does not just contain Python, right? In fact, very little of this is Python. I've got my var1 and my print statement down there. What is the rest of it is Markdown. So each given cell in a Jupyter notebook can either be a coding cell or a Markdown cell. As you can see up at the top, there's a little drop-down menu where you can select that. There are also keyboard shortcuts that allow you to make those changes. So it makes it a very powerful teaching tool, which is why I use it in the classroom, because as you can see here, I can give instructions and provide context for the coding cells, but it's not just teachers who find this Markdown feature useful. I've seen it used widely in conferences for training other coders, but it's also very useful for sharing out your results as a data scientist. So if you want to share with your team or your collaborators work that you've done so that they can understand it, you can use Markdown to provide that context for them. It's very easy to add new cells, to delete them, to copy them. All of those have buttons at the top left, but also keyboard shortcuts. And is there anything else I want to tell you? You can, Jupyter notebooks also support HTML, and they also have their own sort of magic keywords that allow you to do even more fancy things, like change the way results are displayed on the screen. Speaking of the way results are displayed, down here you can see that when I run this print statement, the value that's returned, the print that's printed out just comes right at the bottom there, at the bottom of that particular cell. That's how Jupyter notebooks work. Anytime that you return or print any value, it's going to appear right below the cell. Outputs that are not printed will also return at the bottom of the cell, but that can get tricky if you have multiple outputs returned in a given cell. Only the last one will return. So I recommend using the print statement, even though you may not feel like you need it. So that's the basics of how to use a Jupyter notebook. Now let's talk a little bit about pandas. Pandas is one of the most widely used Python libraries for data science and data analysis. I love this little picture here from real Python, so I thought it was cute, I would add it. But let's dive into pandas. The most important thing about pandas is that it introduces a data structure called the data frame. That's a two-dimensional data structure, basically columns and rows, that you will be using as your primary way of holding onto and manipulating and interacting with your data using pandas. So there are a couple of different ways to create a data frame in pandas. You can build one yourself using a dictionary where you provide all of the data, type it in, but more often you're going to be working with a larger data set stored in maybe as a CSV file, as the example I have here, in which case you can use the pandas function read CSV to just read in that CSV file and turn it into a data frame. So that's what we're doing here in this example from a notebook that I use to teach. As you can see there, the very first thing you do is import your pandas library, use the alias PD, and then the next thing you're almost always going to be doing is creating your first data frame. So that's where, in this case, we're using pd.readCSV to read our CSV file into a data frame. This is what I was mentioning before in terms of just Jupyter Notebook returning a returned value as an output here. The out brackets 3 is an example of that where I didn't use the print statement. And this is what we're looking at here. This is a data frame that I'm going to tell you more about later. But as you can see, it has row IDs. It has headers. These are both really important. In fact, the column header is something that you will be using a lot when you're working with Pandas data frame. But this is the basic idea. You've created a data frame. One thing to know about Pandas philosophy is that generally speaking, you're not encouraged to modify a data frame as it is. If you're going to be sorting it or removing any values or anything like that, the library guides you towards creating a new copy of the data frame and not changing the original data frame. In fact, it will often return a warning if it notices that you're doing that. And I think that's a really nice way that Pandas reinforces good data science practices of always keeping that original copy of your data so you can return to it later and you're not changing its integrity by introducing, by making some changes to it and losing your original version. So it has a little bit of version control just built into it, which I think is pretty cool. So this is our data frame. What do we do next? Well, I'm gonna return to that cycle that I mentioned before of the data science life cycle and the data analysis life cycle. Just to go back a minute to talk about data collection. So where does this data even come from? As I mentioned, in scientific data analysis, it often comes from places like government agencies, academic journals, or experimental data that a scientist or students have collected themselves. I have a couple examples here of data I've actually worked with in the classroom. On the left, you see NASA Earth observations. That's a really great resource for climate data, information about the Earth, anything that a NASA satellite can collect. There you see an example of cloud fraction, and you can download all the data points that went into making that map in a CSV file, and I actually have my students recreate those maps using Python and Pandas. And on the right, you see an example of an astrophysics data set from the Gaia satellite, and we're going to talk more about that in my example later. Let's talk next about data cleaning. I love these graphics. They may be a little bit discouraging, but it's just the reality of data science. These are two questions from the 2016 data science report run by Crowdflower, and they asked, what do data scientists spend the most time doing? And 60% of them said cleaning and organizing data. And then what's the least enjoyable part of data science? Also cleaning and organizing data. So you spend a lot of time doing it and it's not very fun. Well, luckily Pandas can make that as painless as possible. So this is from Dataflare. This is just their examples of ways to cleanse missing data in Python. Now, of course, missing data is only one of the examples of the problems you might encounter with a data set, but it's so common, I figured it's a good example. So things you might want to do are drop missing values, replace missing values, replace them with a scalar value. Maybe you want to control how you're filling. If maybe you want to fill all missing values from whatever value is next in the data set or whatever value was behind them. Well, Pandas has built-in methods to do all of these things. One thing to know about Pandas is a lot of its commands are methods as opposed to functions. So very often you'll be writing data frame, or df, whatever you've named your data frame, dot, and then the method. You can also apply almost all of these methods to just a single column of your data frame as opposed to the whole data frame itself, which is pretty cool in my opinion. So these are the Pandas methods that you would use for each of those steps. There's drop NA, there's fill NA, replace, and fill NA can have an additional method set to backfill there or pad if you want to fill forward. So these are just, this is just a handful. It's extensive, right? Pandas was created to make data science easier. So really any kind of data cleaning that you might want to do, Pandas has a method for it. Before I move on, I'll just say as far as how this applies to my work, this is a step that the students really dig into more in their internship year. I do a lot of this data cleaning for the students because I find that it can be a little overwhelming for them to have to deal with all those things at once. But I will often have them just explore the raw data and start to come up with ideas of how they would clean it. So let's go to my specific example. This is an example of how I apply all the things we've been talking about, and I'll move through more of the steps of the data science lifecycle as we go. So this is an example from star parallax and distance. This is in our astrophysics unit, and this is data from the Tycho Gaia astronomic solution dataset. This is a collection of 2.5 million stars identified by the Gaia Astronomical Observatory. And just to show you where I actually pulled the data down there, this is a publicly available website called Vizier, and you can specify all the kinds of variables that you're looking for, the conditions on your data set, which wavelength, mission, et cetera, et cetera. And I use this interface to grab the data I'm going to be showing you in a minute. just a little bit more context, what's so cool about this data set. Gaia is a satellite sent up by the European Space Agency, and it is vastly expanding our reach in terms of how many stars we have accurate distance and parallax information for. So it's giving astrophysicists an unprecedented view of our galaxy. So it's really exciting and cool. Good data set for our students to explore, for you to explore if you want to. I think it's a cool data set. So how do the students or anyone, how do we do data exploration using pandas with this example? So I'm just showing you some of the very basics here. As you can see, the df.head method allows you just to get a peek, right? In this case, this is not, of course, the entire 2.5 million star data set, although if you had the computing power and wanted to, you could do so, right? There's no limit to the number of rows pandas can handle. But in this case, I have given the students a little subset that has about 900,000 stars. You're not going to want to return all 900,000 rows on your screen to see your entire data frame. So the df.head, the .head method is a really great way to just look at the first 5 rows and get a sense of what you're looking at, what your column headers are called, etc. So in this case, we have the Tycho2 ID, that's just a unique ID for each star. We have information about when the data was collected. We have a couple of pieces of information about the star's location in the night sky. So RA stands for right ascension, DEC is declination, and that's kind of like latitude and longitude for stars. We have some error measurements, which is great and a really cool thing to explore. And then we have parallax, and parallax is the angle that you can use to calculate a star's distance. So here we're using the len, just the built-in Python len function to find out how many rows there are in this data frame, but there's also a .count method you could use if you wanted to. Now I'm showing you what I mentioned before about how you can look at just a single column in your data frame. So maybe you want to explore the minimum, maximum, and the mean of all of your parallax angles. So that's what we're doing here by storing just the parallax column in a variable and then printing out its min, max, and mean. And this is, super rudimentary, but I hope it gives you the impression of the kinds of things you can do, and I hope you're thinking of more ways that you could explore this data, and in fact, Pandas has tools for all of those things. What about variable selection and calculations? This is scientific data, so we very frequently want to perform some calculations and manipulate this data. We may not be satisfied with the raw data. And in fact, as I mentioned before, parallax angle can be used to calculate the distance to a star. So in this case, what we're doing is adding a new column to the data frame. You can do that very simply just by using another data frame index. In this moment, we're creating the header for that column, and then we're defining it, in this case, using this simple formula for calculating distance from parallax angle. And now once we've done that using the .head method, now you can see that we've just added a new distance column to the data frame. So this is, again, a simple example of how easy it is to manipulate, run calculations, and add new columns with that information to your data frame. And then you can just explore that. You can use the same min, max, and mean to get some of the basic statistics for that column. What about data visualization, right? Now that we've run some calculations and generated some new columns, what can we do with it? How do we see what we've done? So we're actually using another library here. I'm not showing the import command, but you're going to be using matplotlib.pyplot for this. The matplotlib.pyplot has a bunch of different plots built into it, including histograms, which we use here. And so this is just an example of showing now the distribution of distances of the stars that were in the TGAS dataset. So right, we've already gone in just a few lines of code from 900,000 rows of star data to a histogram showing you the distribution of distances. So this is the power of pandas and how it empowers you to look at a data set. Just to show off a little bit more of the fancy data visualizations that you can do, this is an example of an HR diagram. You don't really need to worry about what that is. It's an astrophysics diagram, but it compares the brightness of stars to their temperature. Now, this is not from the same data set, just a disclaimer. This is actually from a sample data set that gives you a really pretty distribution. It actually includes some of the rarer types of stars that might not show up in that data set, but I wanted to include them here. This is for students to learn what an HR diagram is. But as you can see here, you can use a color map, and now you're actually getting a very cool representation of everything from a red giant to a blue giant, etc. That pink star in the middle there is our sun. So you can see where our sun is compared to all the other stars that we can observe. So once again, this is using matplotlib, but to process the data and get it into a state ready to go into a graph, you would probably use pandas. So I've already been talking about matplotlib. It goes hand in hand with pandas in terms of taking the data that you've processed in your data frame and putting it into a graphical result that you can interpret. Numpy is another really useful library. You'll probably use it for mathematical calculations and statistics. And then I'm not going to go into machine learning in this talk, but if you were to do that as your next step, scikit-learn is really the library that I recommend for that. We do use machine learning in some of our projects, and if you were to do so, you'd probably want to use scikit-learn. That concludes what I have for you. What I will tell you about is on my GitHub at PyCon 2019 in that repository, there are examples, pretty much everything I've shown you, including that same Jupyter notebook I've been walking through, is there. There are also a number of data sets that you can play around with, one from about coral bleaching, the archaeology of plant materials, sickle cell anemia, and earthquakes in Haiti. So just to give you, or in Chile. So just to give you a wide variety of scientific data sets to get your hands on. I also have a folder in that repository that walks you through how to use a Jupyter notebook, how to use pandas, and shows you how you can access even more of this data yourself. So if you want to start playing around with the things I just talked about, go right to that GitHub repository. And if you want to reach out to me or just chat with me or anything, share more cute pandas pictures, you can do that on Twitter at Gabrielle Rab. So thank you so much. I am happy to answer any questions, and I hope that I'll be able to tell you more about anything you're interested in.
Wow, that was amazing. Thank you so much for that introduction to data science. That was awesome. If anyone has any questions, feel free to post them in the chat, or you can reach out on Twitter, like she said. We'll have her handle. I can put that in the chat.
Yeah, and I can also put my GitHub in there so that anyone.
Awesome, that would be amazing.
It really lets you just, get hands-on with what I just showed you in the presentation.
Excellent. Well, cool. We can hang out for a little bit to see if anyone has any questions.
Yeah. And you feel free to ask me anything if you can think of things you think that your audience would want to know.
Yeah, I think so. Most of our audience has an interest in data science at some level. We're seeing more people at the very beginner level. So for someone who's just getting into data science, for example, with your students, do you give them any kind of advice saying, don't worry, this is so easy, or maybe it's difficult, but if you just do these 3 things, it'll be easier? Is there anything that you find yourself telling to beginners regularly?
Sure. I think that what I would advise is to just try to have fun with it, right? What I think is great about this field is that it's an exploration. And I mean, that's maybe easier for us here at the museum where, you can walk around and look at dinosaur bones and that makes it feel fun. But I think you can find that sense of fun with almost any data set if you think of it as, I'm exploring this data set. I might discover something that no one's ever discovered before, or at least I may find a really cool way of showing this data, right? Going back to the clean, it's hard to keep that in mind sometimes when you're in the 60% of your time spent just cleaning up the data, but there is light at the end of the tunnel. And the other thing I think is helpful to remember is that there is no perfect, and that you're not going to get to a point where you've just that there's everything for sure and you've completed it and you have the perfect data visualization. I think that can get in our way sometimes. It gets in my way sometimes. But to remember that it's always a process, and to be comfortable saying, you know, well, these are limitations. This is something I'm still not sure about. Hopefully that will make people feel more comfortable and make it easier to find it fun.
Awesome. Yeah, that's definitely a great attitude to have towards it. Well, excellent. If that's all we have, then thank you again, Gabrielle for taking the time to share all this information with us. Thank you again to our sponsors. And then for those in the audience, if you have any feedback, feel free to reach out and let us know. Other than that, we'll see you at the next event.
Thank you very much.
All right, you guys all have a great day.